With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. So in this question it is given at room temperature, the equilibrium constant for the reaction P plus Q giving R plus S was calculated to be 4.32. At 425 degrees Celsius, the equilibrium constant became 1.24 into 10 raised to minus 2. So this indicates that the reaction is like 4 options are given. We need to select which of them is correct. Okay. So to begin with, what we can do, start with the reaction given. That is P plus Q giving R plus S at equilibrium. Okay. And here it is given that some data are given. The data are like at temperature T1 is equal to room temperature, which is equal to 298 Kelvin. It is going to be this RT is your room temperature. Okay, this K1 value, that is the equilibrium constant at T1 temperature. K1 I am denoting it by is 4.32. Okay, now when the temperature has been changed from room temperature to 425 degrees Celsius. So it is 425 degrees Celsius. Okay. In Kelvin scale, it would be 425 plus 273, which will give you the value as 698 Kelvin. So at T2 temperature, so it is clear that we have increased the temperature. There is an increase in temperature from room temperature, that is 298 Kelvin to 698 Kelvin. Okay. The value of K2 was found to be how much for the same reaction? It was said it is going to give you the value as 1.24 into 10 raised to minus 2 was the K2 value which was obtained. Now moving forward, if you see option given is like this indicates that the reaction is exothermic. Well, that is, if you see what is happening in this case, making the general observation for this reaction, that is, it is clear that there is an increase in temperature, and with increase in temperature, there is decrease in equilibrium constant value, because it has been changing from 4.32 to 1.24 into 10 raised to minus 2. That is very clear that the K2 value has been, the equilibrium constant value has been decreased. So this will imply that we know K is equal to Kf by Kb, where Kf is your rate constant for forward reaction, and this is your rate constant for backward reaction. And when you say the value is decreasing for equilibrium constant, so it should be clear that the value of Kf is decreasing and the value of Kb is increasing. And we can imply from this that when the Kb value increases, it is clear the rate of backward reaction is more. So you can say the rate of backward reaction is more, and at high temperature, it favors endothermic reaction. So since it is a back reaction and it is endothermic reaction, so we can conclude that the opposite, that is the forward reaction, will be exothermic reaction. And hence, if you see the option number A, that it is an exothermic reaction, will be absolutely correct. The forward reaction is an exothermic reaction. Second option is given as it is an endothermic reaction, which is not the case because it is seen that it is an exothermic reaction. It is difficult to predict, no, because we have predicted that it is going to be an exothermic reaction. So you can cancel this out. Like this is also the incorrect option. Moving forward to the fourth one, that there is no relationship between delta H and delta K. Well, that is not the case. This is also incorrect. Why? Because the relationship between delta H and delta K can be given by the Van 't Hoff equation. Van 't Hoff equation, and the equation states that log of K2 upon K1, where K2 and K1 are your equilibrium constants at temperature T2 and T1, will be equal to how much? It is going to be delta H naught divided by 2.303 R multiplied by 1 upon T1 minus 1 upon T2. So it is very clear that there can be a relationship between K and H, right? So option number D is also incorrect. Therefore, the correct answer will be option number A, that it is a exothermic reaction. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.